Think about the multiplier effect. A small change in autonomous spending has the potential to bring about a huge change in equilibrium output. And when equilibrium output increases, that means an increase in employment and maybe an increase in the standard of living. A decrease in autonomous spending can reduce equilibrium output by quite a bit, and this may be necessary in some cases to keep the economy from overheating. You're beginning to get the idea that changes in autonomous spending can be policy instruments. That is, if we want a larger equilibrium output to increase employment, government could spend more and stimulate the economy. This is called Keynesian fiscal policy. An increase in government spending can bring about a boom. Likewise, a decrease in government spending or government incentives for reduced business spending or reduced consumer spending can rein in the economy, reducing equilibrium output and lowering employment, but perhaps taking the pressure off of inflation. Let's think now about how the multiplier effect can be generalized. That is, how the multiplier effect applies to every conceivable reduction in autonomous spending. Let's start by writing out the formula for economic equilibrium in the macroeconomy according to Keynes. That is, according to Keynes, equilibrium is defined in the spending approach as the point where income is equal to aggregate expenditure, which has several components: consumption, investment or business spending, government spending, and net exports. Now, if we take this equilibrium equation, we can add to it our behavioral equation for consumers. That is, we know that consumers spend A plus BY, where A is autonomous consumption plus B, the marginal propensity to consume, times consumer income. Substitute this equation up here into the equilibrium condition, and you get this. Y is equal to A plus BY plus I plus G plus net exports. Now, next thing you know, we're going to be changing this consumption function to take account of taxes. But for the moment, let's imagine we're in a world where there are no taxes. Well, if that's the case, we can pull this term that has income in it over to the left-hand side of the equation and get 1 minus B times Y is equal to A plus I plus G plus NX. What I've done is to isolate all of these autonomous spending components. Autonomous consumer spending, business spending, government spending, and foreign spending, all of which are independent of the level of income in the economy. The only thing that depends on income is this one component of consumer spending, and now we've moved it over to the other side of the equation. Well, this allows me then to calculate equilibrium income as a function of the marginal propensity to consume and all of these autonomous components. That is, if I divide both sides by 1 minus the marginal propensity to consume, this is what I'm going to get. Equilibrium income is equal to 1 minus the marginal propensity to consume multiplied by A plus I plus G plus NX. Now, how do you interpret this equation? This equation says that if you add up all of the autonomous spending in the economy and you multiply by the reciprocal of 1 minus the marginal propensity to consume, you get equilibrium output. You get the level of GDP that occurs in the economy when things have stabilized. Well, you can use this equation now to predict how a change in any of these components of autonomous spending will influence equilibrium output, and that's what the multiplier is all about. Suppose we focus for a moment on government spending. If the government increased the amount that it spent by $15, how would that affect real gross domestic product and equilibrium? Well, the government spends $15. That becomes then someone's income. They're going to save 2/10 of it, and they're going to spend 8/10 of it. So take those amounts. That tells you how much is passed on to the next stage of the multiplier process as income. Someone's going to save and spend, and things keep working their way out until finally that $15 increase in government spending translates into 1 over 1 minus 8/10. 1 over 2/10, that is 5, is the multiplier. 15 times 5 equals a $75 increase in real gross domestic product. Once you know that the multiplier is 5, then anytime you increase one of these components of autonomous spending, just multiply the increase by 5 and you get the increase in real gross domestic product. It's really that easy. So let's do an example, and we'll work this example out on our chart. Okay, so suppose we start here in this situation where we have aggregate expenditure, and we're going to imagine to start with that we have a closed economy. That is, I'm going to ignore net exports for this example, and I have only consumption, investment spending, and government spending. And let's suppose that investment spending is initially 0, and government spending is initially 0, and consumption spending is equal to 10 plus 8/10 times y. That's the consumption function we've used in previous examples. Well, if that's the case, the equilibrium output is going to be 50. That is, when income is 50, consumers are planning to spend 50, no savings, no investment, and we're in a very simple macroeconomic equilibrium. But let's make things now a little more interesting. Let's add government spending. And let's suppose that government spending is equal to 15. That is, that I put a red line here, a horizontal red line representing government spending, and that's going to be 15 regardless of the level of income. That is, government spending is autonomous. It's independent of the level of output in the economy. No matter what the output is, the government is planning to spend 15. So add that 15 onto whatever consumers are planning to spend, and that results in an upward shift of the aggregate expenditure line by the amount of the increase in government spending. That is, this upward shift right here is delta G. The upward shift is 15. The new intercept is $15 higher than before. The slope is still equal to the marginal propensity to consume. So what happens? The government spends 15. That creates $15 worth of extra income, some of which is spent, some of which is saved. The spending creates additional income, and that process multiplies over and over and over until we wind up with our new equilibrium. Now, according to our formula, the new equilibrium involves an increase in gross domestic product of 15 times the multiplier of 5, or an increase of 75. So the original equilibrium was 50, add 75 to that, and you get the new equilibrium of 125. If the government decided to spend $15 in this model, it ends up creating an additional $75 worth of gross domestic product. 75 plus 50 is a new total of 125. This is what we call expansionary fiscal policy. When the government decides to increase its spending, the aggregate expenditure line shifts up, and the new equilibrium point involves a larger GDP. Now, this would be a good thing for us to do if, in fact, the economy started from a position of unemployment. Let's suppose that 125 is equal to full employment. If that's the case, then with full employment out here at 125, we are originally at an output level of 50, underproducing. That is, we're not providing enough demand to give factories the incentive to hire everyone who wants to work. If we go back to the original setup and we consider that our equilibrium is 50, if 125 is full employment, then the difference between 50 and 125 is an unemployment gap. We have a recessionary gap here, and the recessionary gap is the difference between the equilibrium output and the output that would fully employ the resources in the economy. So Keynes's view of how to solve this problem is to stimulate the economy with government spending, shifting up the aggregate expenditure curve and giving you a new equilibrium at the point of full employment. That's the solution. Government spending stimulates the economy and brings into production those resources that previously didn't have jobs. Now, we can look at this from another perspective. Suppose that we start in a situation, same as we were before, with output of 50, but now we believe that full employment is actually lower. Maybe we think it's down here closer to 25. Well, now what we have is called an inflationary gap. We're trying to produce more output than the economy would produce at full employment. And the only way you can produce more output is through aggressive bidding by bringing people into the labor market that weren't previously working and bidding up the price of raw materials, making companies go out and work harder to get them, to expend more effort to explore for oil and other minerals. All that pushes up prices. So if full employment involves an output of 25 and we're initially at an output of 50, then we've got an inflationary gap. That is, we should be down here in order to keep prices from rising. Well, if we want to get to that point, we have to somehow cause aggregate expenditure to drop. That is, we have to push the aggregate expenditure curve downward until the intersection would give us equilibrium at an output of 25. That is, we've got to get that red curve to move from its initial position to a lower position. And one policy that might accomplish that is one that discourages consumer spending. Perhaps a tax on consumption, perhaps government policy encouraging people to save more. Anything that caused people to decide to reduce their consumer spending would shift the red line downwards. That is, as long as there's a change in autonomous spending, the line shifts down in a parallel fashion. So if instead of having an autonomous spending of 10, people decided to have an autonomous spending of 5 instead, there's been a reduction in A, the letter that represents autonomous consumption, a reduction from 10 to 5. So that $5 reduction in autonomous consumption is multiplied by the multiplier of 5 to give us a reduction in real gross domestic product from 50 to 25. So the $25 reduction in real gross domestic product is the multiplier at work. $5 reduction on autonomous consumption multiplied by 5, the multiplier, gives us a $25 reduction from 50 to 25 in equilibrium real gross domestic product. So you see, this is how things work. You can use any change in autonomous spending and you wind up getting the same analysis. Shift the red curve up, shift the red curve down. You can close an inflationary gap or close a recessionary gap by choosing the right position for the red curve, encouraging or discouraging the autonomous components of spending. One more thing to point out is that you can get a new equilibrium also by changing the marginal propensity to consume. Suppose we keep our intercept here at 10, but we, through some government incentive, encourage people to save more so that the marginal propensity to consume changes, and instead of being 0.8, now it's only 0.5. That is, we've encouraged people to save half of each additional dollar that they receive instead of saving only 1/5. If we have increased the marginal propensity to consume, if we've reduced the marginal propensity to consume, then our aggregate expenditure line is going to get flatter because the slope of the aggregate expenditure line is the marginal propensity to consume. So if people are saving more, this line is going to be flatter, and we're going to have a new equilibrium intercept. Now, what's the new equilibrium intercept going to be? Well, in this case, take your autonomous components of spending and multiply them by the new multiplier. Whenever the marginal propensity to consume was equal to 8/10, the multiplier was 5. But when the marginal propensity to consume is only 1/2, the multiplier is only going to be 2. So originally, in our original example, the autonomous spending totaled 10. That is, the only component of autonomous spending in the original example was A, what consumers were spending. So if you multiply 10 by the multiplier of 2, then you're going to get a new macroeconomic equilibrium with an output not of 50, but of the much lower level of 20. That is, when people are spending less of each additional dollar, the multiplier effect is dampened and weakened. So output is going to be smaller than it was when people were spending more of each additional dollar. When less of it's passed on, then there's less income created at each successive point in the chain. So there you have it, the multiplier effect at work. If you keep the marginal propensity to consume constant, changing autonomous spending shifts the red curve up and down, perhaps to close a recessionary gap or to close an inflationary gap. If you change the marginal propensity to consume itself, the line gets steeper if the MPC gets bigger and flatter if the MPC gets smaller. All of these begin to show us how we can use this graph and Keynes's demand-driven model to explain economic policy and its effect on output.